Expected value. Let's have a look. A spinner has exactly 4 different sectors. In a game, the spinner is spun once. The probability of landing on each sector is given in the table below. And we can see it. If it lands on sector A, the probability of that is 3/5. And the amount of money is 0. I'm sorry. The amount of money that you get for landing on each sector is also shown. Okay, so what do we need to do with that? Work out the cost to play this game so that expected value of the profit for someone playing the game would be minus 0.5. Meaning what? Expected value is actually a loss. That on average, people will lose 50 cents. Okay, so how do we calculate expected value? So expected value, we take probability and we multiply by either a euro, like in this case, because to probability we have euro is assigned, or sometimes we have a number that is assigned to probability. And therefore plus again, or, so someone either lands on A or B, therefore again, probability multiplied by either euro or a number and so on, doesn't matter how many times we need. So here, the expected value will be actually a loss minus 0.5. Okay, so that means that is calculated 3/5 multiplied by the first euro, which is 0, plus next probability 1/20 multiplied by 100 euro, plus then 1/4 again multiplied by 10 euro, plus 1/10, oh, that shouldn't be written 20, 1/10 multiplied by 25 euro. Now, from all of that, so all of that, that is a probability of winning, isn't it? That is a win. But the idea here is about the cost. So where is the cost in this calculation coming in? So even, even if you think about it, you can win, let's say you won 10 euro. But in order for you to enter that game, maybe let's say that cost you 2 euro. So really what you gain from it, your expected value, well, not just expected, but your actual winning will be what? 8, isn't it? Because you paid 2. So that's exactly the idea. From all that win, we take away cost, and therefore we have our expected value. Okay, so here, very simple. I just move because that's a negative, so I'm going to move the cost to the other side and then have all my numbers here. Just quickly write them down again, and then move my minus 0.5 to the other side of the equation, and therefore change the sign to opposite, so plus 0.5. And when we put all of that in our calculator, press equal, we get that the cost here is 10.5. So somebody have to pay 10.5 euro in order to enter the play, and at the end, on average, everyone will lose 50 cents. Okay, now next part. Each spin of the spinner is independent. The first time that is spun, it lands on sector C. So the first one lands on C. The spinner is spun a second time. Find the probability that it lands on sector C again, given that it landed on sector C the first time. Justify your answer. Okay, and this was a very tricky question, okay? Because they were trying to trick you by saying, given that it landed on C sector the first time. So you're thinking, oh, conditional probability, isn't it? Because that's how it works, that event 1 happened, given that the first one happened. However, here, each spin is independent. The fact that first time it landed on sea, it has no influence over the next time landing at sea. So therefore, the probability of getting sea the second time is basically probability of landing on sea, which is 1/4. Yeah, there is nothing that condition the second landing on the first one. Yeah, because each landing is independent. Like, as you know, the most kind of common thing that we use in that conditional probability is the idea that what is the probability of me wearing a jacket in the morning given that it was -5 in the night? Yeah, so that's what I'm saying. Or given that it was +20 in the night. Yeah, so that first event, the temperature at night, will influence the second event of whether I'm wearing a jacket or not. That's basically what it is. But here, each event independent, therefore no connection.